Now we're going to look at another problem that involves wheels and rotation, and definitely watch exercise 11 before 12 because in 11 I talk a lot more about the reasoning behind what we're doing. We're going to try to move a little quicker in this one, number 12. Here we see that the wheels on a bicycle are turning at 80 revolutions per minute, which is often abbreviated as RPMs. So this is our first problem where we're dealing with RPMs. The wheels have a 15-inch radius. How long will it take the bicycle to travel 1 mile? And there are many, many approaches we could take to this, and I'm just going to try to suggest one approach. I don't insist on it, but it's an approach that I find really, really useful, especially when you're not quite sure whether to multiply, whether to divide, or how to set up a problem. This idea of unit analysis or dimensional analysis helps guide you through to the answer, even if you're not exactly sure how to get started. Now, first we see that phrase revolution per minute, and so we do have to think about how the word revolution is being used here. A revolution is 1 full turn of the wheel. So we have these bicycle wheels that I think are 15 inches in radius. And let's draw some ground here. So as the wheel goes around, and we talked about this more in exercise 11, as the wheel goes through 1 revolution, so as the wheel turns around, it's going to end up further on down the line here, right? As around here, maybe that radius is sticking out this way, and by the time it gets here, it's back to its original position. So say 1 full turn of the wheel takes us this distance. Well, that's equal to 1 full revolution of the wheel. The bicycle travels 1 circumference, right, of distance traveled out, which is 2 pi r, or 2 pi times 15. That's 30 pi inches of length. So this distance here, red, is 30 pi inches. Don't lose the pi. It's 30 times pi. It's not just the number 30. So we're going to use that information to solve this problem. And now what do we want here? What do we want? We want to know how long means how much time, right? That phrase long sometimes means distance in English, but here the word long refers to time. How many units of time? We have minutes mentioned, so we can express this in minutes. How many minutes to travel 1 mile? How many minutes to travel 1 mile is the question. And again, there are different ways this problem can be set up, but I'm going to think of this as a rate. I'm going to translate this to how many minutes per mile. So I'm going to go through this dimensional analysis process, and we want to end up with how many minutes per mile at the end of this problem. We want those kind of units. Now the only units that I'm given here in the statement of the problem is that 80 revolutions per minute. So that 80 RPMs now I can write as 80 revolutions per 1 minute. Okay, so that's the same as my 80 RPM, but I'm expressing it as a ratio, as a fraction. And now, when I look at what I'm starting with here and what I want to end up with, I don't like the way these line up because I want minutes in the numerator units of my answer, and in RPMs, minutes are in the denominator. So I'm going to use the reciprocal. And because units are involved, I can turn this ratio upside down and write it as 1 minute per 80 revolutions. That's the same RPM expression, just written as a reciprocal ratio. And that will allow me to keep minutes in the numerator, but now I got some work to do because I want to end up with miles in the denominator, right? So what I want to do is take this initial ratio, 1 minute per 80 revolutions, get revolutions to cancel out, and get miles to appear somehow. So I got to multiply by a ratio that will have revolutions now. I'm going to write the revolutions above because I want it to cancel. And I want some units of distance here. And what I'm going to use is my circumference amount, thought of as the circumference stretched out. Because in one revolution of the wheel, the bicycle travels 30 pi inches. This relationship I'm going to put in this fraction that I'm writing down now. One revolution of the wheel, I travel 30 pi inches. And now the revolutions will cancel out in the multiplication. I'll have minutes per inch. And really, all I got to do now is figure out how to get from minutes per inch to minutes per mile. So let's see. I want inches to cancel. So I want inches above. I know 12 inches equals 1 foot in American units. And now, okay, I think I only have one more step here because I want feet to cancel. And I want to get miles in my final result. I know, actually, you may have to look it up, and it's fine if you do. 5,280 feet equals 1 mile. That's a very, very ancient kind of relationship. And so what I end up with, again, is revolutions canceling, inches canceling, feet canceling. I get minutes per mile. And notice this little tricky step where I use the reciprocal relationship of 80 revolutions per 1 minute. It's still the same information, but it allows me to get my units to turn out to be with minutes in the numerator at the end. And so what do we got here? We got 1 times 12 times 5,280 over 80 times 30 pi, don't lose the pi, times 1, and this will be minutes per mile when I figure that out on my calculator. I think the exact value I get here is 132 over 5 pi minutes to travel 1 mile. So that's the way the original question was worded. I guess that's the exact answer. At any point you can shift to a decimal. For this, it's about 8.4 minutes to travel 1 mile. And I got that 8.4 on my calculator. Okay, so here was our problem. And I'm just going to slowly slide it up to the answer. And that's our RPM problem.